I'm very happy to be here today to talk about monorepos. And right away, I think the first thing most people think when talking about monorepos is the opposite, which is the polyrepo setting. So I'm going to start comparing both approaches. And here you can see like some setups that you may recognize from diagrams that you may have in your company, in your organization. The, I guess, white boxes there are the representation of a repo, and the blue cubes are representing artifacts that these repos produce. So it can be like Docker images or binaries, jars, anything that you get out of the code that you have can be understood as the blue cube. So the first, let me test can you see it? Yeah. The first example here, you have a bunch of repos that have a very clearly defined dependency relationship, and they all together work to produce a single artifact, right? And this is, I think, very common, where people have multiple repos to build like a monolith, and I guess no mystery there. Then we move on to the next one, where we have a single repo, but we also produce a single artifact. So that also already has a question mark here from my side, because is that a monorepo or not? Then moving on, we have a more complicated setting where you have multiple repos that have more dependency relationship, you have code sharing between them, and you produce, in the end, the combination is 3 artifacts. And that, to me, is very clearly a polyrepo setting. Then the last one is what, to me, is also very clearly a monorepo setting. Yeah, I lost the pointer. But you have a single repo, and you have, after a build, you have multiple artifacts, right? Then other complicated cases where it's not so obvious whether it's a monorepo or a polyrepo setting. For example, here you have repos that in a straight line produce a single artifact, and they are not connected with each other in any way. So is that a polyrepo if you don't have sharing of code between multiple artifacts that in the end get produced? Conversely, if you have a single repo and the internal modules do not share any code, it's the analogs of this situation. So can you say that this is a monorepo, or is it just a big repo, right? And then I guess most of us work in a setup that is very similar to this, where you have everything mixed together, and you cannot tell whether or not you're using polyrepo or monorepo or both or neither, right? So a simple way to understand them, in my view, is to say that what defines if a setting of repos that produce artifacts can be understood as a polyrepo or a monorepo setting is the way you share code between these pieces that you have to produce the artifacts, right? So when you add the arrows that represent the dependency relationship between the repos that make artifacts share code, I think you can very clearly say that this is a polyrepo setting. And the same is true for a monorepo setting, where now you have code sharing. Okay, so giving a definition of what a monorepo can be understood as in this presentation, and in my view, you can say that monolithic applications are not always coming from monorepos. I think everyone knows that, right, from your works. Also, putting code together on the same repo does not characterize a monorepo as well, because if you don't have the sharing relationship, then it's just a bunch of modules that are disjoint and produce artifacts from the same place. And of course, to have a monorepo, you have to have very well-defined relationship between them, so you can very distinctively draw the diagram that represent your dependency relationships, right? Also, very important is that the modules on a monorepo are inside are part of the same build system. So most of us, I think, come from a Java background or Go background here, and you're very familiar with Maven builds. So you have a lot of modules that are part of the same reactor build, and this produces a single artifact in the end, or multiple smaller artifacts that may or may not be important to you as far as publication go to a registry, or for third parties to consume, or even first parties to consume. Okay? Then in the blue box are kind of things that are not very well defined when talking about monorepos, but I wanted to give you my opinion and what I understand as a monorepo. So monorepos are not necessarily big in the sense of there's a lot of code there, a mess everywhere, nobody knows what depends on what. No, that's not the case. Also, for me, monorepos are repos that contain code that produce more than one artifact that is interesting to you after the build, right? So if you're publishing, for example, 2 Docker images from one single repo, in my view, that's a monorepo already. And of course, the code sharing. So you need to have ability to a single module in your monorepo to be reused by final artifacts that you have. So that's the definition. We'll build from there, and right off the bat, you can do this claim, right? You can tell me, yeah, but nobody has a monorepo. Everyone has multiple repos, and that is true. It's very rare to see a company that has everything inside the same repository, right? That's not the case at all. So when we talk about monorepos, when we talk about monorepos, we actually are not talking about putting everything inside the same repo. And I'm going to try to explain the way I understand that and how you can benefit from it. So conversely, using the definition that I just gave, you can also say that everyone has a monorepo. Because if you think about repository that has many libraries in it that get published, you have one single repository that publishes multiple artifacts that are interesting after the build, right? So if you have like a multi-module Go repo, or if you have a multi-module Maven repo, for me, you have a monorepo. And that's what I just said. So this session will try to answer this question: should you have a monorepo? And the way I'll try to do that is talking a little bit about code-based structure and how teams operate together, how people do software, and how code reuse is understood and implemented in the industry. And in the end, I hope that by looking at the examples and the experience, that my personal experience that I'm going to share with you, you'll be able to make a more informed decision of whether or not you can benefit from a monorepo, or if you stick to a more traditional polyrepo setting. Now, before we begin, I need to make a big disclaimer, because this is a very complicated subject, and it's really hard to capture the uniqueness of each company or organization or team or project or whatever division that you may have in your job or in your open source contribution workflows. So I'm putting in here because the examples will be oversimplified. We will have tens of repos max, and it's not going to be like a very detailed case study. We're going to talk in more general terms, so more or less everyone can relate in some way and try to abstract a little bit and apply that to your job, right? Then another part of this disclaimer is that since we're talking about how people interact to produce software, this conversation can easily become about management, and the separation that gets done in your companies may be very closely mirroring the structure that you have in your teams and managers and things like that. So just wanted to put this disclaimer out before we begin. Now, let's see an example where our code base is composed by these repos, right? We have 5 microservices at the top, followed by 2 backend for front ends repos. Then we have 2 front end applications, and then we have 5 repos that contain common code. And in the end, we have the end-to-end tests repository. So I guess everyone can relate in some way to this example, although oversimplified. And the experience I had multiple times is very closely related to this, where you present something very simple and all of a sudden everyone has an opinion of what should be done, of what's a better way to do that, or even like personal taste. I like it, I don't like it, whatever, right? So first thing I wanted to talk is, if you're in this situation, chances are you're not ready to have a conversation about whether or not to pursue a polyrepo or a monorepo setting, because you have very fragmented opinions and you don't have people going to the same direction, even if they agree or not. So my advice would be trying to get everyone moving in the same way so that everyone can be exposed to the same problems, understand what comes after them in case of like library building, or in case of like the ops team deploying heavy Docker images or something. So that is the way that this conversation starts. And this is part of the disclaimer too, but also already like piece of advice that this conversation is very slow, very lengthy, and very complex. So it's not something you can decide in a 1-hour meeting when you put like all the stakeholders together or the architects or whatever, and then you say, okay, voting, Monorepo or not. So it's not going to go like that. And very important, I think, and very closely related to all the other talks we had today in the event, people, teams, and your uniqueness, the uniqueness of your operating dynamics come before choosing what to do. And then even if you do decide what to do, having everyone aligned and understanding why you're doing something, put that in writing, document it, make presentations, make people watch them, whatever works for you, comes before actually pursuing that change, implementing Monorepo or Polyrepo, right? So this digression here about differences of opinion, the nature of the discussion itself. Let's continue with our little e-commerce setup with the repos I showed before. And let's break it down in teams, right? We can look at the repos and we can see some affinity between them and the way that I, as the architect or CTO or whatever, and understand how people should be working together. And this is valid, right? I guess it's something that someone is doing somewhere. But also, you could have something like this, where you have different teams, you have different names, you have different operating dynamics, is what I'm calling it, right? And this is very unique to your organization. Nobody's doing software exactly the same way. We're sure borrowing from colleagues and people from other companies, tech presentations, but in reality, the operations is very distinct in wherever you look, right? So this is also valid. And interesting, we have this now, where 3 teams are collaborating on the same repo, right? Okay, good. Oh, and also here, we have all teams collaborating on the end-to-end tests. So that's pretty normal, right? Everyone owns the tests, so nobody does, right? So, and also this is a very valid possibility where you have a big code base, you have your repos there, you have 2 main teams doing stuff everywhere, helping everybody out, and then you have a very focused team here doing only security. So they only care about security. And you have another very focused team that only cares about tests, right? This is also valid. Now, why am I saying all this? Because you as individuals, as decision makers, as multipliers, you know how your team operates much better than me or anyone else that gives advice on the internet or whatever. So by looking at your particular case and evaluating both techniques, both Monorepo and Polyrepo, you can see where you could benefit from each one of them, right? You don't have to choose. You can pick Monorepo for a part of your org or Polyrepo for another part. Okay, so far, list of repos. Everybody had opinions. We sorted that out. Now we have our little team separation here. We know that this is important. And we didn't talk about the dependency relationship between the repos, right? It's somewhat obvious from the names, but even so, people can understand them differently. So this is a possibility. I know there's a lot of arrows, but yeah. So you have the microservices there, depending on a lot of common library repos here. Then they get used by the end-to-end tests. And then you have the front ends, which is like separate. And they have like their own code sharing with the design system or very nasty selects that you implemented. And yeah, this can be something that someone draws in your company by looking at the repos. Or you can see someone understand it like this, where the BFFs actually depend on the user service as a hard dependency and not just like API dependency or something. So this is a valid possibility too. And more than that, these are only the internal arrows that you would have if you would draw this diagram for your company in this example. Now, there's a lot of other arrows which are third-party dependencies that every repo is depending on, right? You cannot build software without depending on them. And to make things more complicated, this is also something that many of us are doing. We're versioning our own libraries and publishing them so that they can be consumed by our services, right? And you can see this becomes very complicated very quickly because it's hard to tell what libraries are being used and what are not, and what versions of services are using what versions of libraries. You get it. So it can be that you see this and you solve it like this. Like, yeah, no, every time a library publishes a release, we have to update all the services to have everyone on the same page, using the same version, no dependency conflicts, everything works. Or you can go one step further and you say, yeah, so every time we make a change on a repo, this gets automatically published to the services. They rebuild, redeploy, do everything. So in this case, I mean, why do we have repos then? You could put everything inside the same repo and call them modules, you know? So it's a possibility. Now, I wanted to go through this example to highlight that making software inherently has these problems. And if you haven't, go watch this talk. It's 7 years old, but it's still current. It's very educational to understand like how software gets built and published. Very, very great material. So yeah, I mean, we can all identify with these problems here. At some point, we had multiple releases just to consume like a tiny library, or we had like one person depending on a version of a library, and then this version has a security vulnerability, so you have to run and update everything. So that's one thing I wanted to say, like, making software is hard. Even if you were in complete isolation, just you and your text editor, pushing characters there is already difficult. Then if you start pointing to third-party dependencies, it gets more difficult because now you have to manage the complexity of upgrading them and tracing them and seeing if they are reliable or not. And then if you want to make your software be reusable by others, then that's even harder because now you have to care about who's using your software. And if you're doing all the same, all at the same time, which is everyone, then this is the hardest thing ever, right? It's really complicated. Taking a step back to the Monorepo and Polyrepo conversation. How can we define them, right, after all this? So Polyrepo is usually understood as very small repos that contain software for a very specific purpose. And they produce a single artifact, or like very few. And every time you publish something from a repo on a Polyrepo setting, you don't care about who's using it. It's their responsibility to get your new version and upgrade their code. Now, on a Monorepo, you have multiple modules that can or cannot be related. And the way you reuse code internally is by just pointing to a local artifact, right? And on purpose, I put that line there saying that builds can be fast on a monorepo, because if you build it right, you can always filter the monorepo and build exactly the part that you want without having to build everything else that's in there, right? That's how you scale a monorepo. Good. So I think we can move to the second example where we have a better understanding of the way I'm presenting Polyrepo versus Monorepo. And this next example has to do with the concepts of upstream and downstream. Many of you may be familiar with it already, especially if you're in a Polyrepo setting. But that's repos in purple, artifacts in blue, and let's imagine you're there, all the way to the right. So what you call upstream is whatever comes before you in the build pipeline. So libraries you use, services you consume, that's upstream. And everything that depends on you, your libraries, your Docker images, your services, that's downstream, okay? So in this example, we have like one repo that's upstream and one repo that's downstream. Pretty easy. But if you're someone making changes to this repo, now your downstream looks like this, which is a lot of stuff, right? And in this cut of the code-based structure, that's the entirety of your publishable artifacts, right? So changing something in that particular repository has implications in all artifacts you produce. Now, let's go through the most common setup to share code, which is publishing libraries using semantic versioning. You can have this setup, and you make a change on the very first one there, where the red arrow is. So what happens is you make a change, then you publish a new version, and then people have to upgrade their dependencies to use that new version. And if you want to continue that and release the new artifact using that new version of that library, then you have to continue that chaining, and you have a new version of this repo, then you publish a new version of this one, then they update the version that they're consuming, then you publish a new version of those repos that represent the artifacts, and then you push the artifacts somewhere, right? So this is how many of us are doing things, and depending on who's doing what, this may be very wasteful, right? I mean, if there's the same team managing all these repos, why are they making all those version publications if their only purpose was to update the artifacts in the first place, right? So you can argue that, well, let's use a monorepo then, and put every component there in a module inside the same repo under the same build system, and then I make a change, and then I release, right? But that's not all good things, because on the last setup, the team doing changes here did their change, published their versions, continued to the next task, right? And then the other teams started upgrading their code. But now you can have something like this, where you have a very big change to make, and you have to make them this change all at once, which can take weeks, right? Especially if you're doing like a major version bump or something. So yeah, so you make the changes, and then you can release. Now, this is the part where I take the responsibility out of me a little bit and hand it over to you, because you know what you're doing, what your code looks like, what your teams prefer, and everything related to the operating dynamics of your code base. So if you look at all this and you say, who's responsible for updating downstream code? Each one of us will have a different answer. And that answer has impact on whether or not you should be using a monorepo. And another question would be, how do you prefer to introduce changes where on a polyrepo, you do it incrementally. A team updates a library, this library gets published, and slowly everyone adopts it, right? Whereas on a monorepo, the team that's changing the library may have to ask for help updating downstream code because they may not have the knowledge, so it may take longer, but once you do it for everyone, so you know that the new artifacts are deployed aligned, right? Now, this is my take. So I don't think Polyrepo and Monorepo are either or. I think they're complementary. And it depends on where you are and what you're doing and who you're doing it with, right? So they're both techniques that can coexist in the same code base, and the way you structure it has to be very tightly coupled with the way you operate it and the way the skill set that people have and everything related to your day-to-day. So here's where you can take a picture. Some parts of your organization are better understood and operated as a detached unit. For example, if you have like a framework team, or you're doing like a CLI team, where you have very distinct workflow, they need to be independent to innovate and publish new versions, and you don't need to force everyone to use the latest version of this tool. That happens, that exists, and it's a valid possibility. Now, the other part is true as well. Some parts of your organization are better understood and operated as a unified conglomerate where alignment and synchronicity are mandatory even for success, you know? So, for me, monorepos or polyrepos is not a question of one or the other. It's a question of where and when you should be using each one of those. Now, the talk ended here, and I wanted to talk a little bit more about my experience working on a monorepo. So we have a fairly big one, I would say. That's the project I work on every day. It's called Apache Key Tools. It's specialized tools for business automation, authoring and running and monitoring and everything. So some stats, our build system is PNPM, and we are almost 5 years old. We have 200 packages, give or take, and each package is understood like a little repo. So each package has a package.json file borrowed from the JavaScript ecosystem that contains a script that defines how to build it. And this package.json file also defines the relationship between the modules themselves. So it's really easy for me to, with simple command, say, I want to build this section of the monorepo and select exact what part of the tree that I want to build. I didn't write it here, but we have almost 50 artifacts coming from that monorepo, ranging from Docker images to VS Code extensions and Maven modules and Maven applications and examples that get published and everything. And the way we put everyone under the same build system was by using standardized script names. So each package that has a build step has two commands called build dev and build prod, and packages that can be standalone developed have a start command. Then all the configuration is done through environment variables, borrowing from the 12-factor app manifesto, I guess. So we have built an internal tool that manages this very big amount of environment variables to configure things like logo paths, or whether or not to turn on the optimizer or minifier or run tests or not. So everything that we do is through environment variables. And every time we need to make a reference to another package, so for example, I'm building a binary that puts together like a bunch of libraries, we do that through the node modules there, also borrowed from the JavaScript ecosystem. So through symbolic links and the definitions we have in package.json, we can safely only reference things that we declare as a dependency. So we're not having a problem where we are just going back to directories and entering another package without declaring it as a dependency. So this is something that we did to prevent ourselves from making mistakes, and during builds that select only a part of the monorepo, forget to build something, right? Then one thing that we have that's very helpful is the ability to partially build the Monorepo in PR checks. So depending on the files you changed, we have a script that will figure out what packages need to be rebuilt, what packages need to be retested, and things like that. So the stats there are for a run, where's the pointer? Here. For a run that changed only a few files in a particular module, the slowest partition built in 16 minutes, and all the other ones were very fast. And for a full build, you can compare the times. So like having the ability to split your builds in partitions and in sections of the tree is very important if you want to have speed on a monorepo that can scale very well. Also, to make things more complicated, we have many languages in there. So we are a polyglot monorepo, and I left that out of the presentation on purpose because it gets complicated very quickly. So just to mention it here, we have Java, libs and apps building with Maven. We have TypeScript, same thing. We have Golang, and we have a lot of container images as well. And another thing, and that's all optimization, is that we have sparse checkout ability. So you can clone the repo and select only a portion of it that you want. So even if it gets really, really big, you can say on the git clone that you only want these packages, and they will be downloaded, and everything else is going to be ignored, and the build system will continue working normally for you. So, of course, not everything is good. We have some challenges and some things that we are doing right now. And one of those things is that we're missing a user manual. So a lot of the knowledge we have is on people's heads and private messages on Slack or Zulip chat for open source. And that's not very good. So we're writing a user manual with all the conventions that we have, the reasoning behind the architecture of the repo and everything. Then we're also improving the development experience for Maven-based packages, especially with importing them in IDEs and making sure that all the references are picked up and things become red when they're wrong and things like that. Then we have a very annoying problem, which is if you change the lock file, the top level one, our partitioning system doesn't understand which modules are affected. But we have a fix for it. We're researching how to roll that out. But I'm glad that we found a solution there. So if that works the way it should, we are never going to have a full build whenever code change, unless it's like a very root level file, like the top level package.json or something. Then we're also pending trying a merge queue. So for those who don't know, merge queue is when you press the merge button, the code doesn't go instantly to the branch, the target branch. It goes to a queue where it simulates merges. And when a check passes, you can merge automatically. So you can take things out of the queue if they are going to break your main branch. And that's a very cool thing to prevent semantic conflicts from happening, especially when they break tasks or something. So we're pending trying that. And also we're pending having multiple cores available for each package to build. So we can do parallel builds, but we don't have a way to say, hey, during your build, you can use this many cores. So we don't have that. We're probably going to use an environment variable for that. So, and next one is related to this. You saw we have two commands to build dev and build prod. And sometimes there's duplication in these commands, and it's very annoying to maintain. So one thing we're researching is how we can use the environment variables to configure parameters that will distinct a prod and a dev build. For example, on Webpack, you can say the mode, and it will like optimize your build or not. And the last one, which I think is the most exciting, is taking advantage of Turborepo, also a task runner that will understand package.json files. And it has a very nice ability, which is caching. So you can, in theory, download our Monorepo and start an app without building anything. So yeah, you can see that how powerful that is for development and for welcoming new people in a code base. But of course, if you look at a Polyrepo, you don't have the caching problem because you're publishing everything, so you don't have to build it again. Anyway, trade-offs. So yeah, I wanted to close with some advice of how can you build a monorepo yourself or even improve existing monorepos that you might have. And the first one is, if you're starting a monorepo now, if you think this is for you, if you're doing research, if you're doing a POC or something, then don't start big. Don't try to hug every part of the code base. Start small, pick a few languages or one, choose one build tool, and go from there, right? You're going to make mistakes. You're going to learn from them. You're going to incorporate the way your organization works. You're going to have feedback. So start small. Don't plan for the whole thing. Then the third bullet point there is choose some defaults, right? Conventionalize from the beginning. Like, this is the way we do it. It doesn't matter if it's good or bad, or you don't know, right? You're just starting. So the important thing is that everyone is doing the same, and everyone is exposed to the exact same environment, so they can feel the same struggles if they happen. Chances there will be some, right? Then fourth is make the relationship between the modules easy to visualize. It's really easy to get lost when you have a monorepo because you have very small modules, and if you don't plan them accordingly, you'll have everyone depending on everything, right? And this is not good. Well, that also happens with a polyrepo, but you get it. Number 5, be prepared to write some custom tools. So your build necessities are very unique too. I mean, maybe your company has a weird setup because of network issues, or maybe you're doing code in a very old platform that needs a very special tool to build, and you need to fetch it from somewhere and use an API key. I don't know. So be prepared to write custom scripts that look like they are already made for you, you know, like tailored for your needs. This is something that's really valuable. And 6th, be prepared to talk about the monorepo a lot, because this is a controversial topic and people will have a lot of opinions, and you will have to explain why you're doing this all over again multiple times, right? Then number 7 is optimize for development, and that comes from my personal experience. It is much nicer for people to clone and start working right away rather than having a massive configuration step, right? So our monorepo has everything turned off by default, everything targeting development, local host all the way, no production names, no production references, nothing, and everything just is made for being ran locally without dependencies on anything, right? Then some don'ts, which are equally important in my opinion. Don't group by technology. So don't look at your code base and think, yeah, let's get everything that is using Rust and put on the same monorepo, because, yeah, everything's Rust. We have a build system built for it, right? No. Group by operating dynamics, by affinity of teams. Talk to people. See how they feel about interacting with other teams more often. Maybe they don't like it, and maybe this is not for them. Or maybe you're putting 2 parts of your code base that are using the same technology but have nothing to do with each other, right? So don't do that. Don't group by technology. Group by team affinity, by the things that you want to build and the way people are already operating. Then number 9, don't compromise on quality. Be thorough about the decisions you make and why you're making them, because otherwise you can become a big ball of mud very quickly. So say no if some people want to like put a bunch of code in your monorepo just to solve like an immediate problem that they might be having. Think about it, structure it, plan, make POCs, simulate what's gonna be like your day-to-day if the code was there, you know. Have patience. And number 10 is don't do too much right away. So I mentioned many things like partial builds, sparse checkouts, what else is there? Caching and thus unified configuration mechanism. So you don't have to have all these things to have a monorepo. Maybe your monorepo is small in the beginning, and it's fine if you have to build everything every time, right? Maybe. And 11th, I think, is the most important one. Don't be afraid if the monorepo doesn't work out for you. Reevaluate, incorporate feedback, learn from your mistakes, and hear people out. Because the goal of all this is to extract the most out of the people's time, right? There's no reason for you to put code in a monorepo if this is going to make people's life harder. And that's true for the opposite direction too. There's no reason to split just because it's more beautiful. I don't know, you know? So number 11 there. And that's it. Thank you so much.
We have a little time for questions.
Thank you so much. This was a great conversation.
Thank you.
Do you have any preference on the build tools? Because we have suffered a lot by choosing one build tool and then we quickly get lost from there.
You mean like choosing Maven over Bazel or Gradle?
You mentioned a lot of tools, so I was wondering which one is your preferred choice, like Gradle or Maven. We can go on about it for an hour.
Yeah, exactly.
Probably.
So this is very closely related to your team's preference and skill set. On my team, it was, and it still is, very hard to get people to move from the Maven state of mind to a less structured approach that we have with like package.json and JavaScript all over the place. So I don't have a preference. I mean, they all are equally good depending on what you're doing. Sorry for not answering your question, but it will depend. Yeah.
But I can talk to you later about it.
Yeah,
It's okay.
Yeah.
I have a question. So, do you have any first-hand opinion on coding styles between the various modules of a monorepo? I'm more interested in a polyglot monorepo, if possible. Like how the code is organized, like various service layers and all that.
Yeah, so this is something I didn't write in the presentation, but that's a great question. And I'm a very big sponsor of flat structures on the monorepo. So I don't like too much nesting because it's easier to visualize the relationship between all the internal modules if you don't have a folder that hides 100 modules, you know? So I always tell people, give the package name a very nice prefix and don't be afraid of creating as many as you want. Like the monorepo that we built is built for thousands of packages, right? We are prepared to grow that far. I mean, IDE support might suffer a little bit, but you know, depending on what IDE you're using too. So I guess this is the most, like the thing that I talk about the most, like flat structures at the top, easy visualization. But if you go to the specifics of each language, then you go to the user manual and you see the code style there.
Yes, thanks so much for this talk. I'm from one of those rare companies that does pretty much use a monorepo for the entire code.
Wow.
So, and there's lots of pros and cons there, of course, and we're actually kind of in the process of trying to unwind that. But anyway, I just wanted to add maybe one don't, actually, to your list, which is try to avoid polyglot repos. Because you can easily get into a situation where you have dependency hell resulting from that. If you have like downstream dependencies from that and upstream dependencies, you have like a Java service that's depending on a Python library being built or something like that. So
yeah. Thank you.
Yeah.
I don't necessarily agree with that don't.
Okay.
But it is a concern. I mean, polyglot monorepos are really fragile and really hard to build. I mean, you can look at stories that people who use Bazel will tell you, and it can become very messy very quickly. But for our use case, for example, we really do have the need of having this cross-language dependency because we're having like a VS Code extension that is TypeScript depending on jars, and these jars usually depend on other TypeScript modules. So the structure that we created lets us navigate this crazy dependency tree that we have in a way that allows us to stay in synchrony, right? So, yeah.
Just to clarify, I was talking about individual repos having multiple languages in them.
Right.
Because, well, maybe it's specific to our company, but
Yeah.
like we have pretty coarse-grained dependencies, so it's like code base.
Exactly, and this is a good example, like your organization, it didn't work out for you, so you're moving out of it, so that's completely fine. But maybe a big part of your modules are staying inside a monorepo, which is fine too, you know? You're deciding where and when, so good.
Thanks for doing this. There's a whole bunch of wisdom in your talk. It was good. I'm right here. When you were talking about your own company's problems, one of the bullets said that you had the package lock file would change, or the PNPM lock file would change, and it was causing downstream things to build, and you fixed that. I got lost. Like, why is it a bad thing for when dependencies change for everything downstream to get rebuilt?
Yeah, so it's not a bad thing. It's actually what we're aiming for. We want to build only downstream things when a dependency changes. But our problem is that when the log file, which is in the root folder, changes, the scripting system that we have to decide what to build will understand that a root file changed, so everything gets built. And now we have a solution where we leverage the turbo repo diffing algorithm to understand which packages are affected by the dependencies that changed inside the lock file. So you're right, like building only downstream when the dependency change is a good thing.